Hello friends, good evening. Hello friends, good evening to all. Karthik, good evening. Ashwini Kumar, good evening. Kavya, good evening. Sandeep, good evening. My dear friends, Charan, God bless you, Sandeep. Please clear one. Hello friends, please tell me, my voice is clearly audible to you? Am I clearly visible to you? And the screen also clearly visible to you. You please tell these three things through the chat box so that we can start the session. Welcome to largest India platform for GATE and IES, my dear friends, that is GATE Academy Global. If anybody did not subscribe, please subscribe to our GATE Academy Global channel. And most important thing is, my dear friends, this Sunday, August 8th, 8 p.m, there will be a scholarship test, my dear friends, at 8 p.m. based on engineering, mathematics and aptitude. So there will be many offers based on that exam that I am going to tell you tomorrow, my dear friends. But this Sunday, means August 8th at 8 p.m, there will be a scholarship test for all the students based on the syllabus of mathematics and as well as aptitude. And if any student is going to get the top rank in that scholarship test, they are going to get 3 months subscription for VOD and some benefits will be there, my dear friends. Therefore, please utilize that scholarship test and get the best so that you will utilize so many opportunities from the GATE Academy, friends. Okay. So without any time delay, people replied, clear sir. Okay. Satish, good evening. Ash, good evening. Rupesh, yes sir. Okay. Dear friends, let me start the number of questions which is pending. I think only few questions are pending from the transmission basics, my dear friends. After this, I know many people are eagerly waiting to understand the power system stability. Okay. So anyhow, we will start the session without any time delay. This was 2006 IIT Kharagpur question, my dear friends, and GATE 2022 paper also conducting by IIT Kharagpur. There was a theory questions in GATE exam from the IIT Kharagpur, my dear friends. Please be careful about theory questions also from the IIT Kharagpur because 2022 paper is conducting by IIT Kharagpur. Tell me, my dear friends, the concept of an electrically short, medium, long transmission line primarily based on physical length of the transmission line. Already we know that answer is going to be B for Bengaluru. That means short transmission line, medium transmission line, long transmission line classification is based on physical length of the transmission line rather than wavelength. Therefore, answer is going to be B for Bengaluru. Lakshmi, good evening. Sandeep is given correct answer. Therefore, B for Bengaluru will be the correct answer. Let us move to another question, my dear friends. This will be the another question. Please calculate this question. The ABCD constants of a 220 kV line, that means ABCD constants for 220 kV transmission line is given. A and D value given, magnitude is 0.94, angle is 1 degree. B, impedance magnitude is 130, angle is 73 degrees. Admittance magnitude is 0.001 and angle of admittance is 90 degrees. Now tell me, friends, if the sending end voltage of the line for a given load delivered at nominal voltage is 240 kilovolts, sending end voltage is given 240 kilovolts, the percentage voltage regulation of the line is very simple question, my dear friends. Let me copy this question to the screen, then we will calculate percentage voltage regulation with respect to this line. So please try to solve this question, my dear engineers. How to calculate percentage voltage regulation? Percentage voltage regulation. Ashwini Kumar, sir, velocity coefficient, incident current concepts we learn or not? Yes, definitely Ashwini Kumar. That is traveling wave concepts that we will discuss after completion of stability. After completion of stability, I will be discussed with traveling wave in overhead transmission lines, underground cables, overhead insulator. These bacha topics we will be discussed after completion of stability. Load flows and stability if completes, my dear friends, power system is going to be bacha subject. So that is the reason why please be tuned with respect to the power system so that we can enjoy the power system as much as possible. Okay, let us complete the solutions right now without any time waste. Tell me, percentage voltage regulation can be calculated by keeping sending end voltage constant, supply frequency constant, and it is the rate change of voltage at the receiving end from no load to full load. This is the percentage voltage regulation, my dear friends. We know that, dear friends, receiving end voltage is given as 220 kilovolts. This is nothing but full load receiving end voltage, nothing but VR. And sending end voltage is given as 240 kilovolts, my dear friends. How to calculate no load receiving end voltage? no load receiving end voltage is equal to Vs by A, where Vs is given how much, my dear friends? 240 kilovolts. Value of A is given 0.94. Therefore, 240 kilovolts divided by 0.9. Please try to give the answers, my dear friends. Good evening, Suresh. 240 divided by 0.9. What will be the answer? 0.94. I am sorry. A value given 0.94. 240 divided by 0.94 is going to be 255. I am sorry, friends. It is going to be not 266. It is going to be 255.3191 kilovolts. This is going to be the no load receiving end voltage. Substitute there. It is 255.319 is the no load receiving end voltage minus full load receiving end voltage is going to be 220 kilovolts divided by full load receiving end voltage also 220 kilovolts. Now tell me, engineers, what will be the answer? Multiplied by how much? 100. Multiplied by 100, so that we will get the percentage voltage regulation in percentage. That is going to be 16.05% is the voltage regulation of this given line. Now tell me, 16.05 means C for Chennai Super Kings will be the correct answer. Now dear friends, many students, when control system will start, Akash Mishra from Indore, just be cool, Akash, soon I am going to start control system, don't worry about this. Please wait for some more days. Like next month I am going to start, Akash Mishra. I am expecting by next month I am going to start. Don't worry about Akash Mishra, but please be tuned to power system. Once power system is completed, we will start the control system. Don't worry, Akash Mishra, I am here, don't fear. This is my common dialogue, my dear friends. Very good. Sandeep is given, Yash is given, 1 Ninokkade is given. Answer is going to be 16.05%. My dear friends, some of the students are also calculating this percentage voltage regulation like this. Percentage voltage regulation, some of the people also calculating like this. That is no load receiving end voltage minus full load receiving end voltage upon full load receiving end voltage multiplied by 100. That means they are converting this receiving end voltage. Whenever it is given by default 3-phase transmission line, the voltage is going to be line to line voltage. Therefore, full load receiving end voltage they are converting into per phase, and then they are calculating. Dear friends, even you are converting into per phase, answer also going to be remain same. Even you are maintaining line to line values, answer also going to be remain same. If you convert this voltage to per phase, convert this also to per phase, so that difference is going to be remain same. There is no change in difference, my dear friends. That is the reason why if you want to convert into phase, per phase, convert every voltage to per phase. If you don't want to convert everything into per phase, then utilize all the values. Answer is going to be simple and same, my dear friends. That means, what is my point is, while calculating voltage regulation, in order to save the time, no need to convert any voltage to per phase, then directly answer is going to, even you are converting into per phase, also answer is going to be remain same. That is very important, my dear friends. Attendance is going to be more important, my dear friends. If you like the session, please fatafat press the like button, then we can enjoy the power system, my dear friends. Attendance is more important. Please press the like button, then we can enjoy the power system, my dear engineers. Let us move to another question without any time waste. Let us move to another question without any time waste. Yeah, this will be the question, really interesting question. So please try to solve this question, my dear friends. This is one of the interesting question. Attendance is more important. If you really enjoying the power system, please press the like button and then share as it is as much as possible, my dear friends. So this will be the question. Please try to solve this question. I am waiting for your answer. Really, it is excellent question. 2007 IIT Kanpur question, my dear friends. So please give me the answer, my dear friends. Please give me the answer. These are simple questions. Maybe in state and central government PSUs also they can ask this kind of questions. That's why those who are not serious about GATE preparation, those who are very serious about central and state government PSUs, for them also please try to utilize these questions, because these are very simple level questions, not difficult level questions. What will be the answer, my dear friends? He given very simply, the total reactance and total susceptance of a lossless overhead transmission line operating at what frequency? 50 Hz is given by 0.045. That means total reactance is nothing but XL. XL is nothing but omega L. Now tell me, omega L is given 0.045 per unit is the XL value. And total susceptance also given, friends. Total susceptance, that is capacitive susceptance, BC is equal to omega C. It is JXL, basically it is JBC, and this is J omega L and this is J omega C. J omega C given, my dear friends, 1.2 per unit. That means total reactance of the transmission line given, total susceptance of the transmission line is given. If velocity of the wave propagation is given as 3 into 10 power 5 kilometer per second, velocity of wave traveling, small v, is equal to 3 into 10 power 5 kilometer per second is the velocity of wave traveling, engineers. Then the approximate length of the transmission line is. Approximate length of the transmission line. Dear friends, yesterday only we have discussed velocity by frequency equal to 2 pi divided by beta. These are the things we have discussed yesterday class only. From this beta equal to 2 pi f divided by velocity. This is per kilometer. Why? Because we are calculating everything per kilometer. Now dear friends, if you want to calculate for total length, that is for L kilometers, beta is going to be 2 pi f L divided by velocity. Now tell me, what is unknown? Length of the transmission line is unknown. That means we have to calculate length. Frequency is given 50 Hz. Velocity of wave traveling also given 3 into wave propagation also given 3 into 10 power 5 kilometer per second. And next one is beta is unknown, my dear friends. Now tell me how to calculate beta. Beta is going to be under root J omega L into J omega C. Already yesterday only we discussed beta is going to be quadrature constant, which is imaginary part of the propagation constant. Tell me, J omega L is given how much, my dear engineers? Directly 0.045 multiplied with J omega C value is given how much? 1.2. Therefore beta is going to be under root of this, under root of 0.045 multiplied with 1.2. is going to be, beta is going to be 0.2324, my dear friends, beta. Substitute here, beta is going to be 0.2324 is equal to 2 pi into frequency is going to be 50 Hz. Length of the transmission line we have to calculate. Velocity is going to be 3 into 10 power 5. From this, tell me length is going to be how much? What is the answer? Length is going to be 221.90 kilometers. Any option? 221.90 kilometers is going to be C for Chennai Super Kings, my dear friends. 222 kilometers approximately will be the length of the transmission line, my dear friends. Tell me any doubts here? Very good. Sandeep is given correct answer. Yash is given correct answer. Ashwini Kumar given correct answer. Neenokkadne given correct answer. Superb, superb, superb. Really powerful, my dear friends. Very good. Fantastic. If anybody have doubts, please ask me. I can repeat the question. I will repeat the solution. Lalit Mahavar also added. Very good, very good. Our strength is increasing. I am very much happy. Lalit Mahavar also given C will be the correct answer. Very good, friends. Length of the transmission line is going to be 221.90 kilometers will be the correct answer, or 222 kilometers will be the correct answer. Can I move to another question? I hope everybody understand this question. Let us move to another question without any time waste. Please calculate this question. IAS Bangalore question. IIS Bangalore question. Please try to solve this question, my dear friends. I am waiting for your results. Please try to solve this question, my dear friends. What is the question? An extra high voltage transmission line length of 300 kilometers. Tell me, length of the transmission line is given 300 kilometers. Length is given as L is given 300 kilometers. Can be approximated by a lossless line having a propagation constant. Beta is given. Propagation constant, that means it is lossless transmission line. In case of lossless transmission line, there is no attenuation constant. Therefore, beta is going to be 0.00127 radians per kilometer is given. This is the quadrature constant. Then the percentage ratio of line to wavelength will be, that means line length to the wavelength. Then he is asking what is the percentage of the line length to wavelength, the ratio of line length to wavelength. Tell me how to calculate wavelength, my dear engineers. Wavelength can be calculated lambda equal to 2 pi by beta. Already beta value is given, my dear friends. That is 2 pi divided by beta is given 0.00127. May I know what is the answer for this question, please? 2 pi divided by 0.00127. The wavelength is going to be 4947.39 kilometers. Units of numerator is radians. Units for denominator is radian per kilometer. Therefore, overall units is going to be para, that is kilometer. Therefore, wavelength is going to be 4947 kilometers. Line length already given, engineers, is going to be 300 kilometers. Line length is 300 kilometers. Wavelength already we calculated 4947.39 kilometers. This is very, very important. Now, 300 divided by answer will be, the answer is, he is asking in percentage, that means multiplied by 100. After multiplying by 100, the percentage is going to be 6.06 percentage. 6.06 percentage will be the correct answer. D for Delhi will be the correct answer, my dear friends. Okay, very good. S is given correct answer. D for Delhi will be the correct answer. But I need to explain many concepts here. If you are really having more interest, stay tuned so that you will understand many things here. I think everybody got the concept. Please reply once in the chat box. If everybody got the concept, then I will move to the one small concept here. I want to discuss one small concept here. If everybody got this concept, please reply in the chat box. I will explain one small concept related to this question. Always I used to tell one statement in the offline classes. Since last 10 years I am having experience in the gate field in this country, that means our beloved country India. Always I used to tell one important statement to my dear students. My dear Priya Vidyarthiyo, even I am explaining power system very high level manner, nearer to the sky. Students can understand 80%. There will be 20% voltage drop from my side to your side when wave is traveling from my side to your side. That remaining 20% of power system you will understand by solving so many numericals. Today one of my student, Sujal from Jabalpur, the student is sent that same message in WhatsApp. Sir, you are correct. Subject we can able to understand, even though I teach excellent manner, you can understand only 80% of the subject. 20% there will be a gap because of we are practical people. That 20% gap we can fill by solving so many numericals. That's the reason why, my dear friends, GATE exam almost 99.99% questions are going to be numerical questions. That is the reason why please stay tuned. If you are able to solve more number of questions, definitely you are going to kill the subject very easily. And there is a very less chances that you can forget the subject. There will be more chances you can remember the subject forever, my dear friends. That is the reason why solve more questions, enjoy the power system. Okay, let me explain one beautiful concept here. Listen, dear friends, in this question beta is given. In this question what is given? Beta is given. So beta is given, we have completed the solution. Sometimes in the GATE question paper they will not give beta, my dear friends. Whenever they will not give beta, for lossless transmission line, practical results I am telling to you, my dear friends. For lossless transmission line means resistance equal to 0, conductance is equal to 0. For this transmission line, if beta is not given, please consider this value for the calculation, that is 1.047 radians per kilometer. will be the correct answer. Sorry. I'm sorry. 1.047 into 10 power minus 3 radians per kilometer is the value of beta whenever it did not given in the question, my dear friends. In order to calculate wavelength, we have to take this standard value, that is quadrature constant is going to be 1.047 into 10 power minus 3 radians per kilometer will be taken if it is going to be lossless transmission line. Please note all these points. This is very, very important, my dear friends. And if you really enjoying the power system, please, attendance is more important. Please press the like button and share as much as possible to your juniors and friends group, my dear friends. Listen concentrately. Lossless transmission line is given. This is going to be the quadrature constant. Suppose if lossy transmission line is given, my dear friends, if lossy transmission line is given, my dear friends, beta is going to be selected greater than 1.047 into 10 power minus 3 radians per kilometer. This is going to be the beta value, quadrature constant value whenever lossy transmission line is given. That means lossy transmission line means there is a attenuation constant alpha, because resistance is not considered as 0, conductance also not considered as 0. This is going to be very, very important, my dear friends. Please note all these values. Whenever they are asking to calculate beta, that is wavelength, at the time these values are going to be more powerful. Maximum time they are going to give questions related to lossless transmission line. At the time beta value will be selected as 1.047 into 10 power minus 3 radians per kilometer. If lossy transmission line is given, this beta value will be selected for like this. This is going to be more important even for PSU, state and central government exams, my dear friends. And one more most important thing I want to tell here is characteristic impedance of overhead transmission line typically is going to be 400 ohms. Characteristic impedance of overhead transmission line typically it is going to be 400 ohms. Overhead transmission line, OHTL, overhead transmission line. For underground cable, characteristic impedance is going to be 40 ohms. It is 1 by 10 times of the characteristic impedance of the overhead transmission line, that is 10 times will be less in case of underground cable. If he is asking in the range, the characteristic impedance of overhead transmission line is going to be 200 to 500 ohms. That means it is characteristic impedance of overhead transmission line exists in between the range of 200 to 500. Particularly if anybody is asking what is the particular value of characteristic impedance in case of overhead transmission line is going to be 400 ohms. Dear friends, if anybody is asking characteristic impedance of underground cable in the range, if anybody is asking, you can give answer in interview, that is going to be 40 ohms to 80 ohms, and particularly one value in case of underground cable is 40 ohms. Dear friends, characteristic impedance is going to be depends on inductance per kilometer and capacitance per kilometer. Dear friends, in overhead transmission line inductance is more, therefore characteristic impedance is more. In case of underground cable, my dear friends, we will discuss all these things, don't worry. Capacitance value is going to be more severe, therefore characteristic impedance value is going to be very much less compared to overhead line. In case of underground cable, capacitance is going to be very much severe, because of that characteristic impedance of underground cable is going to be less when compared to overhead transmission line. This is very, very important, my dear friends. Please try to remember, if any times if they are not giving this type of values, you have to utilize this data to calculate transmission line questions. I think everybody got the concepts. Hello friends, everybody got the concepts? Please note all these things. Please note all these things, my dear friends. If you noted, then I will move forward direction. Please confirm once everybody noted these points or not. I will explain why characteristic impedance in overhead line is 400 ohms, that I will in traveling wave of overhead transmission line I explain, and in case of underground cable I will explain why characteristic impedance of underground cable is going to be 40 ohms. Those two things I will explain with respect to proof. Practically I will explain these two concepts, but we have to wait for traveling wave in overhead transmission lines and underground cable discussion, my dear friends. Okay, very good, my dear friends. Done. Then let us move to another question. Let's move to another question. This is going to be voltage control question. Okay, please tell me what is the answer for this question. 2009 IIT Roorkee question. 2009 IIT Roorkee question, my dear friends. Can anybody give the answer for this question, my dear friends? Can anybody give the answer for this question? Very good, very good. Superb, superb. Noted, sir. Everybody following me. Thank you, my dear friends. Ashwini Kumar, sir, we are making notes simultaneously like offline class. Very good, my dear friends. Already I have shared the PDF of previous control system and power system questions of IIT Kharagpur in Telegram channel, my dear friends. And I become so much of lazy to send the PDF per unit representation. I will send, my dear friends. Soon I am going to send. Saurabh Soni is given. C is the correct answer. Very good, powerful. Saurabh Soni, congratulations. Your answer is going to be correct. That is going to be 1 by V square. Listen. For a fixed value of complex power flow in transmission line having a sending end voltage is V, sending end voltage given as V, the power loss is going to be proportional to what? You know, dear friends, power loss, what is the formula? Simple concept. Power loss is going to be I square, or is the loss is going to be in transmission line due to resistance. Now tell me, power loss is going to be I square, or we know, friends, the total power S is equal to what? S is equal to V into I. From this, I is equal to S by V, that is complex power. He is given data in terms of complex power and operating voltage, my dear friends. Therefore, the current I am converting into complex power as well as operating voltage. Now tell me, power loss is equal to I square is nothing but S square divided by V square multiplied by R. Now you tell me, what is the statement is given? For a fixed value of complex power flow and value of resistance also fixed, because he did not speak about that. Then sending end voltage is assumed as V. Tell me, power loss is inversely proportional to square of the voltage, that is square of sending end voltage. Hence, answer is going to be, proportional to 1 by V square, or inversely proportional to square of the voltage. That will be the answer, my dear friends. Very good. Satish given C, Sandeep given C, Kalyani Reddy given C, Srinath is given C. Very good. S is equal to VI conjugate. Very good. But even you take conjugate here, very good question. One of the friend is asking question, S is equal to VI conjugate. Even you take the conjugate here, S conjugate by V conjugate. Anyhow, we require the power loss in terms of magnitude. So, no need of sign here, my dear friends. Therefore, I have ignored the conjugate, but while calculating reactive power, conjugate is going to be compulsory, my dear friends. Interesting. Very good, my dear friends. Now tell me, answer is going to be C. So, completed. Let's move to another question. This is a bacha question really, already many times I have repeated this. Dear friends, transmission line have two series element, that is resistance and inductance. In parallel, that is going to be conductance as well as capacitance. Conductance as well as capacitance. This is R, this is L, this is G, this is C. Now tell me, under ideal condition, transmission line is represented by flat line. Very important concept. Please do understand. In interviews, these questions are more common. Under ideal condition, transmission line is represented by either flat line, or second is going to be infinite line, or third is going to be tuned line, or fourth is going to be none of the above. What is the answer? Under ideal condition in power system, always transmission line is represented by flat line. Flat line is the one which can maintain constant voltage at the sending end as well as constant voltage at the receiving end. That means nature of the transmission line is going to be resistive nature. Inductive reactive power of Li square equal to half CV square. In case of voltage control, I will explain all these concepts, my dear friends. Therefore, under ideal case, always we are going to represent the transmission line by flat line. Very good. Answer is going to be R into C is equal to L into Z. A will be the correct answer, but try to understand the concept, my dear friends. A for Andhra Pradesh will be the correct answer. Superb, my dear friends. Let us concentrate on the discussion. Ideal case transmission line is represented by flat line. Flat line meaning is, it is a line which is maintaining constant voltage at the sending end, constant voltage at the receiving end. Reason, resistance present in the transmission line, no inductance, no capacitance effect. Therefore, inductive reactive power of the inductor, capacitive reactive power of the capacitor, both are going to be nullified. Then we can say there is no reactive power in the transmission line. Total power is equal to real power. This is going to be ideal case. Then you have a question, sir, why transmission line is not represented by infinite line? Why transmission line is not represented by tuned line in case of ideal case? This is the most interesting question. Dear friends, we have to tune this inductor as well as this capacitor with the help of filters. Very important. we have to tune the inductor as well as capacitor in the transmission line with the help of filters. Which filter we are going to use? In control system you studied, the name of the filters is going to be low pass filter, high pass filter, band pass filter, band elimination filter, and all pass filter. These are the filters which is available in control system and analog circuits, both we have studied. Network analysis also you have studied, my dear friends. We have to use low pass filter in power system. Why? Because frequency of Indian power system is going to be 50 Hz, which is very low value compared to communication line. Therefore, the frequency of power lines, the power frequency in case of transmission lines is going to be very much less compared to power frequency of communication lines. That is the reason why we require a low pass filter in order to tune the transmission line. By tuning the inductor and capacitor, because both elements are depends on frequency, with the help of low pass filter, we have to get the ratio such that R by L equal to G by C. That means, dear friends, in series, which is going to be dominant? Inductance is going to be dominant. In parallel, which is going to be dominant? Capacitance is going to be dominant. That means, with respect to inductance, resistance is almost negligible. With respect to capacitance, conductance is almost negligible. This is going to be explaining distortionless transmission line or lossless transmission line. This condition also can be written as R into C is equal to G into L. Whether this one or this one is satisfied with the help of low pass filter, if you tune inductor and capacitor, then we can say it is going to be distortionless transmission line. Now answer is going to be R into C is equal to G into L. This will be the most interesting concept, my dear friends. Now tell me, why we are not representing ideally transmission line by tuned line? Because throughout the length of the transmission line we required to arrange the low pass filter. This is going to be more costly, which is uneconomical. That's the reason why, my dear friends, we are not going to represent transmission line as tuned line, or infinite line is the one which can maintain always constant voltage, constant frequency. That is also not possible practically. Infinite line is always completely having ideal characteristics. That's the reason why ideally we are representing by flat line, my dear friends. So this is the concept that we have to follow. Transmission line under ideal case is represented by flat line, but not by infinite line, but not by tuned line. These concepts I will be explained in case of voltage control. So, but this is the condition for lossless transmission line. R by L equal to G by C, or R into C is equal to G by L. Friends, we can give the answer directly, but why I am explaining this much means, always as a student you have to understand what is the origin, what is the end. That means what is starting, what is ending. In between you are studying completely, then you are going to be stronger while practicing the so many questions. Directly if I am giving answer, then what is the use? There is nothing will be useful to the students level. Am I correct? Saurabh Soni, where I can find the telegram? I will give the telegram link at end of the class, Saurabh Soni, don't worry about that. Okay. Yeah, Sandeep Saha is replied, Vishnu Sir, power system discussion GA. So this is the telegram name, telegram link name. Saurabh Soni, it is already in the chat box. Sandeep Saha sent the telegram link name. Vishnu Sir, power system discussion GA, means Gate Academy. This is the telegram link. If anybody did not join in the telegram link, please join in the telegram link and also share our information to remaining your groups and friends, so that everybody can enjoy our power system, my dear friends. Okay, thank you. Okay, let us move. This is going to be the concept. Yeah, this is one of the interesting question, my dear friends. Please try to solve this question. Almost we are at ending of the transmission line. So we will start the power system stability soon, my dear friends. So many people are waiting for power system stability. Let us, come on, solve this question. Solve this question. Yeah, please solve this question, my dear friends. Sir, when will be stability start? Srinath, I know that you are taking deep breath to start the stability, but some of the interesting questions will be there, Srinath. I am really helping for you guys. I am really want to take care of you guys. If I want to stability, I can attract each and every of my student. That means attraction is very easy, but love is difficult. Love is going to be permanent. Attraction is simple. So if I am not solving this question, see, directly I am starting stability. Maybe I will get excellent feedback of today class, but in gate exam, after writing the gate exam, if you are not able to solve any question in transmission line, at that time you people are thinking Vishnu Sir is cheated. That I don't require, my dear friends. I want to explain each and everything. That is the reason why I am waiting for stability. I am also more eager. I am also getting bored in this topic. I want to switch over to stability, but still I am loving you guys. That's the reason why I am explaining more questions. Please do understand. We will start stability soon, my dear friends. Okay. Starting new topic is really not a big thing for me, but completing a previous topic is going to be a big thing with successfully. That is going to be more important. Okay. So please solve this question. What the question is given? 400 kilometer long. Definitely when 400 kilometer long is given, don't judge this length of the transmission line. Look at the frequency. Based on the frequency, just judge the transmission line. If frequency is not given, by default you have to assume it is going to be 50 Hz frequency. Whenever you are going to assume it is going to be 50 Hz frequency, no doubt when length is going to be more than 160 km, that is comes under long transmission line. Series impedance is given, my dear friends, which is how much? J.5 ohms per kilometer. Now tell me, small z is given. Small z is given how much, my dear friends? J.5 ohms per kilometer. Now tell me, what is the total impedance? Total impedance is going to be small z multiplied by L, which is going to be J.5 multiplied by 400 kilometers. Will be the how much answer, my dear friend? J 200 ohms is the total impedance. This is very, very important. Next, shunt admittance of the transmission line is given. What is the shunt admittance per kilometer? Small y is given, my dear friends. Small y is given how much? J5 micromho per kilometer. Now tell me, what is the overall admittance? Capital Y is equal to y into L, where y is j into 5 and L is going to be 400. Now j 2000 into micro is 10 power minus 6 mhos or Siemens. This is going to be total admittance. Then he is asking magnitude of series impedance. Magnitude of series impedance in ohms in equivalent pi circuit of transmission line is. Now dear friends, many students get confused here whether this question is related to nominal pi circuit, sir, or long transmission line, sir. Now students are getting confused. Sir, here it is given long transmission line, sir, and here it is given equivalent pi model, sir. Then we have to use the formula of pi model or long transmission line. Do friends, do understand, my dear friends, long transmission line, already I have explained very clearly. On that day attendance is very poor and today more people are attending. How you people are going to be catching my concepts? Maybe you are following my recorded videos. That means after class many people are listening. That is very fine, my dear guys. Now tell me, this is going to be what look like a T circuit. This is going to be T circuit and this is going to be a pi circuit. Dear friends, long transmission line is a combination of T and pi circuit. That means pi circuit is a part of long transmission line. Therefore, don't get confused, my dear friends. Don't get confused, my dear friends. Even whenever it is given pi circuit means that is under long transmission line only, because length of the transmission line is more than 160 km. Therefore, that is basically comes under long transmission line. Don't get confused. That is equivalent pi circuit means we have to use the pi circuit questions, formulas, sir. No, that pi circuit is a part of long transmission line. Therefore, we have to use long transmission line formula only. Tell me, series impedance long transmission line formula. B is equal to, what is the formula? Z into 1 plus yz by x. Z into 1 plus yz by x. Dear friends, also we have one more formula. Series impedance of long transmission line is Zc into sin h gamma L. But don't use this formula. We are not mathematical engineers. We are electrical engineers. Use the electrical concepts. Don't use these formulas. Okay. Already this formula I have derived from this only. Am I correct? So impedance is known how much, my dear friends? J 200 ohms multiplied with 1 plus. Already these things I have explained. Please go through long transmission line. If anybody missed, answer came already. Sandeep Saha answer came 186.4. Let me check, Sandeep, if it is correct or not. But I am appreciating you because you given the answer, at least whether it is right or wrong. Your response is very good. I like you. I love you. Now tell me 1 plus y is going to be how much? J 2000 into 10 power minus 6 multiplied by impedance is going to be J 200 ohms divided by how much, friends? 6. Now please calculate this slowly, smoothly and tell me the answers, my dear engineers. I multiplied with divided by 6 plus 1 multiplied by 200. Very good. Superb. Sandeep is correct answer. J 186.66 ohms is the series impedance. J 186.66 will be the series impedance answer. Superb. Sandeep Saha, love you too, sir. Always my love is there with respect to each and every person. Nino Kadne also given correct answer. Yashu also given correct answer. But where is J? You are missing the J. Means you are not accurate people. You are giving 90% answer but not 100% answer, my dear friends. Please correct your mistakes. It is going to be J 186.66 ohms will be the correct answer, my dear friends. Kalyani Reddy also given 186.66 will be the correct answer. Superb, superb. Can anybody calculate what will be the shunt admittance of the long transmission line? I am waiting for your answer. What is the shunt admittance of the long transmission line? Oh, Srinath, they asked in magnitude, sir. Oh my God. Srinath is killed me. Oh, nice. Srinath is studied the question more powerful than me. Okay, okay. Sandeep, yes, I have understood. Okay, anyhow, but you must be accurate. Very good, my dear friends. They have asked magnitude. That's the reason why 186.66 ohms. But anyhow, you please continue all these things. But I mean is, don't miss the J value. If you miss the J value when resistance is included, at the time generally by the flow you will do more mistakes. That is my mean. Okay. Very good. Srinath, Sandeep, Saha, both are very good. Tell me, dear friends, what will be the admittance of this question? What will be the admittance? Already I have explained the formula. Admittance is going to be, admittance is represented by C. Shunt element is represented by C. C is equal to Y into 1 plus YZ by 6. This will be the admittance of the long transmission line. Now tell me, Y is going to be J2 into 10 power minus 3 multiplied with 1 plus J2 into 10 power minus 3 and Z is going to be J200 ohms divided by 6. This is going to be the admittance of the long transmission line. Can anybody give the answer? What will be the answer? Is J 1.8666 into 10 power minus 3 mho is the admittance of the long transmission line. Very good. Ashwini Kumar given, S is given, J 00. Yes, correct. S is given correct answer. Ashwini given correct answer. Srinath is given correct answer. Superb. Superb, my dear friends. Superb. Very good. Nice. So how to calculate A and D values for the long transmission line? A value is going to be 1 plus YZ by 2 and D value also going to be 1 plus YZ by 2. Use these values to get the value of A and value of D in case of long transmission line, my dear friends. Okay. I hope everybody got the question. Let us move to another question, my dear friends, without any time waste. Without any time waste, let us move to another question. Yeah. This is also 2006 IAS Bangalore question. Really powerful question. Let me get the answer from you people side. Let us give the answer for this question. Please. Please give the answer for this question, my dear engineers. I am waiting for your answer. I am waiting for your answer, my dear engineers. If you are really enjoying the session, please press the like button. Attendance is more important, my dear engineers. Attendance is more important. Please press the like button. If you are really enjoying the PowerStem class, please press the like button and also share as much as possible to your friends and groups, my dear friends. Attendance is more important, my dear engineers. So what will be the solution for this question? Question is very simple. At no load condition, he given 3-phase 50 Hz, frequency given 50 Hz, lossless power transmission line has a sending and receiving end voltage. Sending end voltage 400 kilovolts, receiving end voltage is going to be 420 kilovolts. Tell me, sending end voltage is going to be 400 kilovolts, receiving end voltage is going to be 420 kilovolts. But do understand here, he given very simple statement at beginning. Each and every point is important. This is nothing but no load condition. At no load condition, the voltage at the receiving end is 420. That is nothing but no load receiving end voltage. Now tell me, no load receiving end voltage is how much, my dear engineers? 420 kilovolts. We know that VR0 equal to Vs by A is the formula. From this, A value can be calculated. A value is going to be Vs divided by VR0. Can anybody give the answer? A value is going to be 400 divided by 420. So 40 divided by 40 divided by 42. What will be the answer? May I know, please? A value is going to be, value of A is going to be 0.9524 is the value of A, is approximately. Value of A is 0.9524 is the value of A. But what is the question? Assuming velocity of the travelling wave is equivalent to velocity of the light. That means velocity of the travelling wave is equivalent to light means 3 into 10 power 5 kilometer per second, and length of the transmission line in kilometers will be. That means what is the length of the transmission line in kilometers is asking. Tell me friends, once again same concept. Wavelength is going to be velocity by frequency, which is equal to 2 pi by beta, which is going to be 2 pi by beta. We know from this beta is equal to 2 pi f divided by velocity. This is going to be per kilometer. For length of the transmission line is L kilometers. This is going to be beta L. Am I correct, my dear friends? Now we know that friends, A value is going to be 1 minus beta square by 2, where this beta is going to be overall length. Okay, beta is going to be, let beta is going to be 2 pi fl by v. A value known friends and beta value unknown. If you calculate beta from this, we can complete the solution for that. Am I correct? Now tell me how to calculate this one. I am waiting for your answers. How to calculate this value? All people are given value of A. All people are given. Saurabh Soni does not find the channel on the Telegram with his name. I will give you Saurabh Soni. End of the class I will give the link. Don't worry. Please concentrate right now on the class so that you will enjoy the more power system. At end of the class definitely I will give the link, my dear friend. Please wait. Please wait. At end of the link I will provide the. At end of the class I will provide the link. So please stay tuned, Saurabh Soni, and try to give these answers. What will be the answers? What will be the answer, my dear friends? Length of the transmission line is unknown. First calculate beta per kilometer, because dear friends, calculate beta per kilometer. So beta will be calculated as 2 pi f by velocity, which is 2 pi into 50 divided by velocity is going to be 3 into 10 power 5 kilometer per second. Now tell me how much it is? 100 pi divided by 3 into 10 power 5. Beta value is going to be, friends, value of beta is going to be 1.0471 into 10 power minus 3. 1.0471 multiplied by 10 power minus 3. A value is nothing but A is equal to 1 minus beta square L square. Already friends, we know that it is per kilometer. Now for L kilometers, what is beta? Beta L whole square. That means beta square L square divided by 2. Already yesterday I have explained these formulas. A value known. A value is how much? 0.9524 is equal to 1 minus beta square is 1.047 into 10 power minus 3 whole square multiplied by L square divided by 2. Okay. Now tell me, friends, L square equal to, you got 86844.75. From this under root answer is going to be, friends, L is equal to 294.69 kilometers will be the length of the transmission line. So length of the transmission line is going to be 294.694 kilometer will be the correct answer. Ashwini Kumar given correct answer. S is slightly increase. Value S given 302 kilometers. Srinath given 296. Very good. 296 approx 295. Srinath is given 295. Finally, Ashwini Kumar also given 296 kilometers. Therefore, very good friends. 294.69 kilometers. How? Ashwini Kumar, why? Sorry. S is given, answer is very close. 302. Why? How S? That a small difference is came. Where you did mistake, please correct, my dear friend. So when beta value not given, already I have explained. Same formula already explained. Beta is not given. You have to take 1.047 multiplied by 10 power minus 3. Just before some time I have explained. For lossless transmission line, lossless transmission line, beta value will be selected as 1.047 multiplied by 10 power minus 3. Just before some time I have explained the beta value for a lossless transmission line. If it is going to be lossy transmission line, velocity of wave traveling is going to be reduced. Automatically beta value is going to be more than 1.047 into 10 power minus 3. Very good. S is corrected. Very good. All people are corrected the answer. That means given the correct answer. Answer is going to be 294.69 kilometers will be the correct answer. Superb. So please solve this question. IIT Roorkee question 2017. IIT Roorkee question 2017. Please try to solve this question, my dear friends. Please give me the answer. Srinath, sir, we are not getting exact value, then in examination which answer we need to keep? 294 or 295? No. In examination hall, whatever the answer you got, Srinath, it is the filling the blank question. Whatever the answer you got, please fill that same answer in the filling the blank. That will be the correct answer, because sometimes they are asking, it is all, see, very good. Actually the question is now what I want to explain, this question is suitable. See, Srinath, not only Srinath, remaining friends, it is the filling the blank question. Srinath also asked a question, sir, what is the answer that we have tried, 294 or 295? Dear friends, please see the filling the blank question. After that, they given something here. Give the answer up to 1 decimal place. That will be the correct answer. That means for previous question 294.6, 1 decimal after the point, that will be the correct answer. Then only your answer will be correct, otherwise it is going to be wrong. Therefore, Srinath, you understand my point? Ashwini Kumar, enjoying next level power system. Thank you, sir. Very good. Welcome. So this is the point. That means we have to write the answer exactly what you got, but we have to maintain according to what is asking. He is asked 1 decimal place. Therefore, for this question, you have to maintain at least 1 digit after the point. That means we have to get the correct answer. Listen. The nominal pi circuit of a transmission line is given. No doubt. In nominal pi circuit, impedance is not dividing, admittance divided. Tell me, generally friends, in case of nominal pi circuit, impedance is going to be remain same Z, but admittance is divided as 2 parts. Half of the admittance is placed at the sending end, remaining half of the admittance placed at the receiving end. That means admittance is going to be y by 2. But instead of y by 2, what is given here? X is given. Therefore, y by 2 equal to x. From this, admittance is going to be 2 by x, not x by 2, sorry. Admittance is going to be what? 2 by x. Sorry, my dear friends, I am sorry, I get confused here. See, admittance is y by 2, but is given reactance in the line. Reactance is nothing but 1 by admittance. Reactance is 1 by admittance. Therefore, what is admittance here? 1 by x. Y is given 1 by x here. Listen, y by 2 is admittance in pi circuit, that is equal to 1 by x, because he given reactance. Shunt element is going to be not reactance, it is susceptance or admittance. Therefore, we have to take it as 1 by x. Now tell me, y by 2 is equal to 1 by x. From this, y is equal to 2 by x. Admittance in this question is y is equal to 2 by x. Now given friends, impedance already given, which is 100 at an angle 80 degrees ohms. Reactance in the line is given 3300 ohms. Now tell me, what is admittance of the line? 2 divided by 3300. This is going to be the admittance. Then the magnitude of characteristic impedance of the transmission line in ohms. Characteristic impedance of the transmission line is going to be under root Z by Y. Under root Z by Y. We know this formula, my dear friends. Whenever under root Z by Y, if you want to use, Z value is going to be how much already given? Magnitude is given 100, Y value given 2 by 3300. 2 by 3300. Where is my calculator? Now tell me what will be the answer, my dear engineers. 100 multiplied by 3300 divided by 2 under root answer is going to be 406.201 ohms will be the correct answer. So now Srinath is asked to previous question, sir, so what value we have to take here, sir? We have to take according to the given statement. Give the answer up to 1 decibel. Give the answer up to 1 decibel means what, my dear friends? Answer is going to be 406.2 ohms will be the correct answer. That means we given up to 1 decimal after the point. If you are giving one more decimal, that is well and good. If they are asking up to 2 decimals means 20 ohms. Up to 3 decimal means 0.201 ohms. According to given data, we have to maintain answers like this in the gate question paper, my dear friends. It is not going to be approximated like this. This is going to be more powerful concept in case of transmission line, my dear engineers. I think everybody got the concept here. Srinath, have you understand? Very good, my dear friends. If anybody enjoying the Power STEM class today live, please press the like button and share as much as possible, my dear friends. This is going to be a request from my side because we need to be popular so that many people can enjoy our Power STEM class. So please press the like button. Attendance is going to be more important, my dear friends. Attendance is going to be more important. Tanjim, if you use square root of b by c, square root of b by c, b is nothing but z, c is nothing but y. That is answer also going to be same. Then answer is different, sir. Tanjim, no, b is nothing but z, c is going to be y, but we have to calculate y according to the twist. Same answer you are going to get. Why you are using, my dear Tanjim? My dear Tanjim, why we are using b by c? Already z and y is known, directly use that. Why you are going to take like risk, right? Yashwant, yes, sir, definitely. Okay, thank you, my dear friends. So please press the like button if you are really enjoying the Power STEM and share as much as possible, my dear friends. This is the answer for this question. Let us move to another question, my dear friends. Yeah, 2019 IIT Madras question. This will be the question. Please try to solve this question, my dear friends. Come on. Tanjim, no sir, in pi network C is not Y. C is going to be Y by 2. That's why I told. The twist is given related to admittance, Tanjim. You want to make you confused, but already have explained clearly how to select Y value. Please just follow the previous question explanation, then you will get the answer. Okay? I think Tanjim, explanation is given clearly from my side. You please go through once. Definitely you will going to get the answer. Okay? Dear friends, please solve the question. The beautiful question is there on the screen. Please solve the question. Please solve the question. So question is 3-phase 50 Hz 400 kV transmission line. 50 Hz frequency, transmission line voltage is given 400 kV. Length of the transmission line is how much? 300 kilometers. Length of the transmission line is given 300 kilometers. Very good. The line inductance is 1 millihenry per kilometer. Actually, the 1 is going to be here. The line inductance is going to be 1 millihenry per kilometer per phase, and capacitance is going to be 0.01 microfarad per kilometer per phase. The line is under open circuit condition at the receiving end, energized with a 400 kV. Now tell me, sending end voltage is given at what? Sending end voltage is given as 400 kV, my dear engineers. Sending end voltage is given as 400 kV. The receiving end voltage in the kilovolts. That means, we know friends, no load receiving end voltage is equal to Vs by A. That means, Vs value already given. What is unknown? A value is unknown. If you calculate A value, solution is completed, my dear engineers. This is going to be the powerful. Tanjeem, C is going to be y into 1 plus yz by 4. Oh, that is admittance. Yeah, Tanjeem, I think you have taken overall admittance for the pi circuit is going to be y into 1 plus yz. You are correct, but for this question, admittance is going to be only shunt element. Tanjeev, I think you have taken. Tanjeev, I have explained differently. You have assumed that C is going to be overall. Maybe you can, I will give you answer, Tanjeev. I will give you answer in the Telegram group so that you will be satisfied because that question is already gone. So in the live class, if I take more time for that question, people are going to be irritated. I will give you personally answer in the case of Telegram channel. Tanjeem, don't worry about that. Let us focus for this question. So as a student, improve one quality. If you are not able to solve previous question, you are more irritated about previous question, plus leave it. Chhod do means leave it. Immediately go to next question. Come to stability as early as possible so that your mind will be refreshed. Automatically you can attack that question at the end so that that answer also will come. That is going to be more important point, my dear friends. Okay. So VR0, no load receiving end voltage is equal to Vs by A, which is equal to 400 kilovolts by A. Vs is given. Now A is going to be unknown. How to calculate A? A is going to be, what is the formula, my dear friends? A is going to be 1 minus beta square divided by 2. A is going to be this formula already we discussed. Now beta is unknown. When beta is unknown, we know that, friends, velocity by frequency is equal to 2 pi by beta. This formula already you remembered. From this, beta is equal to 2 pi f divided by velocity. It is with respect to per kilometer. For overall kilometer multiplied by length. Now frequency given, length is given. What is unknown? Velocity is unknown. Now tell me how to calculate velocity of the transmission line is going to be 1 by root LC. I did not explain this formula. This is going to be discussed in case of what, my dear friends? In traveling wave, I will explain this concept. Velocity of the overhead transmission line is going to be velocity of traveling wave is going to be 1 by root LC. Please remember, my dear friends, this formula for a while because this concept is still not completed, but we will complete this question. My dear friends, velocity is going to be 1 by root LC, where L is going to be 1 milli, that is 1 into 10 power minus 3. Already given 1 milli Henry per kilometer. Capacitance is given 0.01 microfarad. Now tell me 0.01 microfarad, 0.01 multiplied by 10 power minus 6. This is going to be the velocity. Now tell me 0.01 multiplied with 10 power minus 9 under root of answer. 1 divided by answer. So velocity is going to be 3.16227 into 10 power 5 kilometer per second is the velocity of the traveling wave. Okay. So this velocity is completed, my dear engineers. Sahil Soni, live app student, sir. Okay. Wait, so Sahil, we will enjoy the power system. So beta is going to be calculated right now. 2 pi into frequency is 50 hertz. Length is given how much, my dear friends? Length is given 300 kilometers divided by velocity is going to be 3.16. 100 into pi multiplied with 300 divided by 3.16 into 10 power 5. Sorry. Beta is going to be, friends, 0.2982. 0.2982. A is going to be 1 minus 0.2982 whole square divided by 2. A value is going to be, friends, 0.9555. A value is going to be 0.9555. Now 400 kilovolts divided by 0.9555. So 400 divided by answer is going to be, no load receiving end voltage is going to be 418.61 kilovolts will be the correct answer. Rounded off to 2 decimal places. Rounded off to 2 decimal places means 418.619 kilovolts. I kilovolts. 3 decimals as he asked 2 decimals. Therefore, 418.69. 418.619 kilovolts will be the correct answer at the receiving end voltage under no load condition, my dear friends. Tell me, everybody understand the concept? Very good. Tanjim is came to the line once again. Very good. That is spirit. That is spirit. That's why always I am saying, if you are not understanding previous question, don't think too much on that question. Come to next question immediately. At end of the class, whatever the question is not understand, repeat once again that question. You can kill that question. Tanjim is came to the live one. Tanjim is came to the line once again, my dear friend. It is very good. Fantastic. I am appreciating Tanjim. Ashwini Kumar, Tanjim, Srinath, Sandeep Saha given little bit improvement of answer. Maybe taken 421 because he is approximated. That's why little bit slightly it is going to be higher. But okay, no problem. But anyhow, that is going to be within the limits. We can accept that voltage, that is 421 kilovolts also. No problem, my dear friends. Very good. Let us complete this one. Any doubts in this case? No doubt. Let us move to the next question, my dear friends. Sorry. This will be the question. IIT Roorkee question. Please solve this question, my dear engineers. Please solve this question so that transmission is going to be completed today. We will start stability if time permits. We will start stability if time permits. Please complete the question, my dear friends. Sir, I have taken 0.95. That's the reason why, Sandeep, your answer is going to be slightly varied. But take the complete value. At least 4 digits you have to take. In stability class, it is going to be more important, my dear friends. That's the reason why. Please focus. Sane Srinath. Sir, please take on Sunday per unit fault transmission line marathon for revision. I will plan Sunday. I will plan Srinath. Definitely I will plan. Don't worry. But marathon session means I am afraid whether more students will appear or not. If more attendance is there, more enthusiasm, more energetic. But you are not helping me because you are not sharing our class information to remaining your friends. What will be the answer? Consider a overhead transmission line with 3-phase 50 Hz. Okay, balanced system with conductors located at vertices of an equilateral triangle DAB, DBC, DCA equal to 1 meter. That is going to be, this length is 1 meter and this length also 1 meter, this length also 1 meter. Now tell me, it is going to be symmetrical configuration or unsymmetrical configuration? Symmetrical configuration. The resistance of the conductors neglected, very good, is helping like anything. Geometric and mean radius, GMR also given, very good, my god, he is given complete details, no need to calculate anything. GMR is 0.01 meter. GMD, what is the shortcut of GMD? GMD is shortcut cube root of XYZ. XYZ is 1 into 1 into 1, which is nothing but 1 meter. Already GMR given 1 meter, GMD also 1 meter. Neglecting the effect of ground, the magnitude of positive sequence reactance in ohms per kilometer. Tell me, positive sequence reactance is going to be XL. XL is equal to omega L or 2 pi FL. Now 2 pi F is known, 2 pi into 50, and what is unknown? Inductance is unknown. Now tell me, inductance we have to calculate right now. Inductance is equal to 0.2 ln GMD divided by GMR. Have you remembered these concepts? Have you remembered these concepts? What is the answer? 0.2 ln GMD is going to be 1 meter, GMR is going to be 0.01. Tell me, what will be the answer? Ln of 1 divided by 0.01 multiplied with 0.2. This is going to be 0.9210 millihenry per kilometer. Millihenry per kilometer. Now tell me, engineers, it is going to be 0.9210 milli. Reactance units is going to be ohms per kilometer. Okay. Now multiplied with 100 multiplied with pi. 289.3513 milli ohms per kilometer. But what is the question? Question is going to be asking in ohms per kilometer. Whenever he is asking ohms per kilometer, what is this value is going to be? 0.289 ohms per kilometer is the inductive reactance. Now tell me, rounded off the 3 decimal places. 3 decimal places I rounded. That is going to be 0.289 ohms per kilometer is the correct answer, my dear friends. Okay. This will be the concept. Very good. 0.289. Superb. All people are given perfect answers. Sandeep is given 289.35. Sandeep, Srinath is given same answer. Tanjeem is given same answer previously. Sandeep is given 0.921. Oh my god. Oh, inductance. Fine. But what is the final answer? Final answer is going to be according to the question. Question is given ohms per kilometer. We got milli ohms because inductance is milli-henry. Therefore, answer is going to be in ohms is going to be 0.29893513 is the ohms per kilometer is the inductance, inductive reactance. Sandeep once again done blunder, sir. No problem, Sandeep. In the classroom I am here. Don't fear because I am going to correct your mistakes. But in exam hall, nobody will help you. Therefore, whatever the mistakes you are doing right now here, please try to overcome. Note that mistakes in one short notebook. Small book we have to take. In that book, put the heading of power system and put the heading of concept, that is transmission line basics. In that where you did mistake, in that short notebook, power system and transmission line concept, I did this mistake, like that immediately write in that book, so that you will not do mistake in that book, so that will be helpful before going to GATE exam. Revise that small short notebook where you did mistakes in the power system, where you did mistakes in the control system, and where you did mistakes in the other subjects. Write in that small book before going to exam. Read that book once again. Oh, I did mistakes in this area. I will not do that mistakes in this area in a GATE exam. Like that, we have to motivate yourself so that nothing will be happening, my dear friends. Okay. So please maintain one small book. Please maintain one small book, my dear friends. Automatically, that small book, write this mistakes. What is mistake is happened right now? That mistake you write in the small book. Automatically, that book is going to be. Srinath, sir. Yes, sir. That is the best way. Yes, Srinath. This is my experience. Since my 10 years I am teaching across the country, I have seen so many things. That's the reason why, based on that experience, I am telling to you, my dear friends. So please take one small book, very small book, like a pocket book. Please put the heading power system, the topic, what the mistake you did in the topic, write in immediately in that book. Okay, and then before going to GATE exam or before solving any questions in power system, what are the mistakes you did in that particular topic, revise once, then automatically you will overcome that mistakes, my dear friends. Otherwise, mistakes will be continued. Automatically negative marks also will increase, GATE rank also going to be increased. That means far away from first rank, so that you have to spend one more year. But I am not praying that one. I am really praying to God, each and every of my student will be successful for upcoming GATE 2022 question paper. Okay. Tanjeem, I am unable to attend your classes daily due to DFCCIL class. Okay, no problem, Tanjeem. Even you are unable to attend my daily class, whenever you are free, if a live class and your timing is free, then attend the live class. If not able to attend the live, then please go to recorded. That means after completion of live also it is available in the GATE Academy Global playlists. In that you can find my videos, you can also enjoy the class. Okay, but if possible, try to come to the live, because if you are coming to the live, what will be the advantage? You can interact with me. You can interact with me in the chat box. Whenever you are interacting with me in the chat box, if you have any doubts, definitely I am going to help you. Whenever you are not in the live, what will be the small problem is, everything data is everything which is available in the video, but what the problem is you are unable to interact with me. But anyhow, the Telegram link will be there. To the Telegram link also you are able to interact with me. Okay. Ashwini Kumar, sir, you never compromised with content. We feel like a paid course. A very thank you, sir. See, this is from my heart. I am teaching from my heart. I am not teaching from my throat. If I am teaching from my throat, automatically I can miss the content. If I am teaching from heart, nothing will be missed. So, my energy and my effort will be always constant, my dear friends. Therefore, please share my videos. Actually, I become very weak in the online. I was so much of popular in the offline. More than 50,000 students are listened my class in the offline across the country. More than 30 famous cities I have taken the classes. Each and every city, Kolkata, thousands and thousands of students. Delhi, thousands and thousands of students. Pune, Pune is the most memorable place. After completion of one batch power system, almost 160 students are waiting for me outside at end of the last day of the power system class. All the students did compete that they want to take selfie with me. That is really amazing. In Delhi and Kolkata, many students are touching my food. Really, those days are like heaven to me, really heaven to me. But unfortunately, I am not active in the social media, my dear friends. That's the reason why I become today like this. I become like a normal person. But no problem, I am starting from beginning. Definitely, my commitment is high level. With the help of you, I am going to reach once again high level in the online platform, so that in each and every corner of the country, our beloved country India, students can enjoy my power system classes. This I am expecting. No, Lalit, I did not came to Jaipur. Jaipur I didn't came because more like I have more always I am having class more at Delhi, Indore, Bhopal, Gwalior, these places, and Kolkata, Pune, Hyderabad, Bangalore, these cities I have taken more class. I didn't find time to come to Jaipur. Sorry, Lalit. Sir, soon we will be lesson for online, sir. Thank you, Sandeep, but many students are enjoying my class. That is going to be more important. Avik, I like your teaching, sir. Thank you, Avik. Thank you so much, sir. Tanjim, thank you so much, sir. Super content you are delivering. Thank you so much, Sandeep, Tanjim. Gaming with GHR, yes sir, learning concept through questions. Thank you. Definitely I will spread this video, sir, in all my accounts. Thank you, Tanjim. Remaining people also please take care me, like Tanjim. Tanjim is said that he is going to spread my videos through all his accounts. So you remaining people also, if you do that one, it is going to be more benefits to me, and also I become more popular, so that many students can enjoy my classes, so that their life also going to be settled, my dear friends. Is like a mutual. I am requesting each and everybody, please try to follow my classes, and also please try to share my videos to maximum to the country, so that each and every person can enjoy, my dear friends. Okay, thank you so much. Today is 7:22. Can I start stability? Only 7 minutes time will be there. So with 7 minutes time I am unable to explain more. Tomorrow I am going to start, don't worry. I am here, don't fear. Please don't mind. I am sorry guys. Today also I disappointed you by putting the heading in the YouTube is power system stability, but still I am teaching transmission line basics. Don't worry, my dear friends. Please believe me. Pakka, as transmission is khatam ho gaya, that means completed. Tomorrow 100% I am going to start power system stability. I am the king of the topic. You can challenge this one. I am challenging this one. I am the king of this topic. You will enjoy more practical subject in power system stability, but more patience is required, my dear friends. Without patience I am unable. So I am sorry. Without patience I am unable, my dear friends. With patience, those who are with me, power system stability is going to be killed by any person in the country. Let's see, dear friends. Tomorrow 6 p.m. Don't forget. Please put reminder. We will enjoy the power system stability, my dear friends. Love you. Thank you. Bye-bye. Really, you are going to be more supportable to me this time. I am feeling you are like my family members. My family is going to be very big. I am feeling. Thank you, my dear friends. Love you. Bye-bye. Love you. Bye-bye. Until then, tomorrow up to 6 p.m. Tomorrow 6 p.m. Don't forget, my dear friends. We will enjoy the stability. Stability is another level of power system. Tanjim, very excited to learn from you stability. Yes, Tanjim, I am the Brock Lesnar in what I can say. Bill Goldberg, Brock Lesnar, Undertaker. 3 people will be appeared in case of stability topic. Wait for you, my dear friends. Thank you, dear friends. Thank you, my dear friends. Bye-bye. Good night. Love you. Bye.